Hello everybody and welcome to the channel. My name's Alan and this channel is all about CNC plasma cutting from the ground up. Over the next however many videos it takes, we're going to use this glorious pile of parts to create a fully featured CNC plasma cutter right here in this shop. And when we're done building, I'm going to open source all of it. Our table is going to have a 1 meter by 1 meter cutting area. That's roughly 39 inches by 39 inches in freedom units. It's also going to have all the bells and whistles. Initial height sensing, torch height control, integrated computer, meaning no ancient laptop. It's going to have a water table. It's going to have collision detection. It's going to have switchless homing. It's going to have air pressure sensing for those with smaller compressors and touchscreen operation. And whatever else I can think of between now and when we're done. And if you think I look too dumb to pull it off, well, the smaller prototype, its little brother, is right over there. Let's take a look. This is Darkstar. I called it that because it's murdered out, but it's as bright as the sun whenever it's cutting. Clever I'm not. About a year ago, I wanted to cut out some rear taillight holders for our tractor. So I did the reasonable thing and designed and built from scratch a CNC plasma cutter. I had absolutely no experience with CNC or plasma cutting or really metalworking in general at the time, but given enough time and money, it's amazing what you can do just as long as you don't know how hard it's going to be when you start. So taking a look around, you can see first of all a very sturdy, very dirty stainless steel water table. Up top on the gantry here, we have a one-piece carriage that includes the torch holder and the X and Z motors. There's a float switch inside of here. The Z motor is on the top, X motor is hidden away on the back here, and our blowback torch mounted on the front here. There's a laser under here for indicating our position over the material if we want to start a cut in a random spot. And this is a blowback torch with a currently missing ohmic clip for ohmic sensing. That gives us the initial height sensing so we can find the Z0 on very thin material. The gantry has two motors, one on each side. You'll notice that there's no home or limit switches here. We'll talk later about how we get away without home and limit switches while still having homing. In the electrical cabinet down here, we have a single board computer, so no grungy old laptop hanging out, along with a controller board that I designed and built myself. Make sure you like and subscribe because I will be releasing the schematics for that once we're all done here. The board also has an integrated torch height controller for cutting warped or less than flat materials. So now the tractor has taillights and I have a pretty okay, fully featured DIY home-built CNC plasma cutter. Our task in this series of videos coming up is to build a larger, more professional, more squared away big brother for Darkstar here. Oh, and if you got any suggestions for names, leave them in the comments. So now let's go back to the parts table and take a look at what we're gonna need to create this thing. I'm gonna start with the motion system because that's what really makes this table interesting. Here we have two different sizes of rectangular tubing. The small one is for the Y carriages, and this big one is for the X carriage. Inside of these carriages will be these polycarbonate wheels, 4 per carriage. The carriages move on 20/40 V-slot rail. This one's silver. In reality, we're going to use black. Some people like to bag on V-slot rail, saying it's not stiff enough. For contact cutting, like milling, that may be true, but we are doing non-contact jet cutting, so this is more than rigid enough for our purposes. Bolted onto the carriages, we're gonna have these stepper motors. There's one on each Y-axis, so we've got 2 Y-axis motors. This one for X, and a non-captive linear screw motor for the Z-axis. We're using a belt and pinion arrangement. I really like belt and pinion. It's very economical, very simple. It uses half as much belt, which is a little cheaper, but also there's much less opportunity for backlash, which is really nice, and it's very compact. You don't really need any special tensioners or anything. You just need these double screw T-nuts on each end. All of the cables will run inside these drag chains. This is a bit small. We're gonna use larger ones that are still inside this box. The whole thing will be controlled by this custom driver board. This includes 2 driver chips that do 2 motors each, so for a total of 4. The torch height control is integrated, pressure sensor, all kinds of goodies. And the brain is this Raspberry Pi. It's going to be running real-time Linux, so we're going to have a true real-time system, which is real nice. And our control software is going to be Linux CNC using a custom driver for this board that I wrote. So another interesting thing is this guy, a proper machine torch. This is made by Inwelt. It is a PMX M65 torch with a very nice Euro Central adapter, very clean setup. This is more or less a copy of a Hypertherm torch. It's not exactly the same thing, but it does use the Hypertherm consumables, which is very, very nice. So that's just a little quickie tour of the most interesting components that are going into this. Believe me, there's much more to it. In future videos, we're going to go through every bit of this step by step, you know, from the control board to the e-stop switch. Like I mentioned before, when we're all done here, when it's up and running, I'm going to release everything open source. That includes the CAD drawings and the schematics. So if you're into metalworking, CNC in general, or just cool technology, or just like to do things yourself, make sure you like and subscribe to get all the info. And until next time, get back to work.